Welcome to 2014 question A-1. So in this question we've got drawings shows the projections of a set of soccer goalposts. So here's our elevation, plan and end view. Ball is positioned at P for 2 penalty kicks during a World Cup match. So ball here positioned on the floor in P on the horizontal plane, right, and it's going to be kicked at the goal, and here's a position in plan view, a distance out from the goal. The ball travels in a straight line and hits the net each time. So ball just travels in a straight line, no curling, no anything like that. Part A, so the line PS in plan shows the start of the flight path of the ball from the first penalty kick. So PS is the direction of our first penalty kick. Ball crosses the goal line at a height that is halfway between the ground line and the crossbar. Okay, so it passes the goal line. So here's the position of the goal line, right? That's it in elevation, and in end elevation, here's our goal line. So halfway. So P, it's going to kick from P and travel halfway through the goal line between the crossbar and the ground. Draw the projections of the full flight path. So we're going to start off here by finding halfway up that goal line by bisecting the distance between the ground and the post there. So bisect that distance. Okay, so the flight of the ball for SP or PS is going to be from P, traveling there halfway through the goal. It's going to hit that section of the net. Okay, I'll just highlight that path in yellow. Okay, so now what we can do is we can use basic orthographic projection techniques to find that flight path. So I'm just to use 7 set squares here. Okay, and it's going to travel from SP. It's going to travel in this direction. Okay, that's the height the ball is going to travel. So we need to project that back down here into our plan. Okay, so that's where it hits that part of the net. Okay, and I'll just highlight that in my plan view. So that's flight path PS. And then we'll just find that in our elevation as well. So let's find position of P here as well. It's going to be on the ground line. Okay, so that's the first flight path PS. Okay, tick that off. Part B. Similarly, the line PT, so here's PT, which makes an angle of 15 degrees with the ground, right? So it's going to travel at 15 degrees, and with the ground shows the flight path of the second ball for a penalty kick. Draw the full projections, or draw the projections of the full flight. So we can't just measure 15 degrees here in my end elevation, because we can see it's traveling out at an angle there. Okay, so it'll be sloping back away from P there. So what we need to do is we'll just show the flight path here, because we know this is the one part we do know about it. So it's going to travel from P through T. Okay, and we know in reality that it's going to be traveling up from P on the ground. It's traveling up at an angle of 15 degrees. Okay, so let's create a triangular plane or lamina that is going to be 15 degrees So we'll rotate that 15 degree lambda down and see it here, and that will give us a height. So my protractor, set it up, I just have to extend this line on a little bit so I can measure it more accurately. Rightly. So from P, (15 degrees), okay, then we'll set up our plane then using sliding set squares. So that is 15 degrees here. Okay, and I'll just shade that in lightly just to show it. That is a plane that we've created. It's a 15 degree angle. And it's a right angle triangle. So if you imagine, that is actually, in reality, that is, you know, rotated up. That's the path of the ball, okay, traveling at 15 degrees. So that has given us the height the ball travels at. Okay, so we can take that height, okay, and we can step that height up in our elevation in our plan. Or sorry, end elevation. So project vertically up. Okay, and that is the height that the ball has travelled. So I can get this height. Step it up there. So let's highlight that again. I'm going to say that this, find a different pencil. So this height and this height, they're equal. Okay, so that is the flight path of PT. And that is where it hits the back of the net. So I can project across there, where it hits the back of the net. So here's PT. I'll just highlight those. PT, PT, and there's PT also. Okay, so I'll just label my distances there. So that's PS, PS, PT, P, T, and PS. T. Okay, so that is 2014 question A1, a nice kind of problem solving question.